Hey there, today we'll continue with a new lesson about object-oriented programming. Specifically, we'll be talking about fields and properties. Be aware, this video is part of a playlist, so if there are things that don't make sense to you, you may want to watch previous videos first. With that said, let's start. So first, let's establish what a field is. You saw in previous lessons that we can have classes that can contain stuff like methods and even variables directly, like this. And this is what a field is, a variable declared directly inside the body of a class. Opposed to that, a variable declared inside the body of a method is called a local variable because it's local to that method. It's only visible inside the body of that method, like this. In fact, if you remember from the lesson about variable scopes, a variable is visible in the block of code where it's declared in, plus any inner child blocks no matter how deeply nested. In our case, current stock is visible in the body of the book class because it's declared in that block of code, plus any inner child blocks like for example body of methods. So this is visible here. We are using current stock, which is declared in the body of the book class, inside the body of the cell method. I was also explaining in the previous lesson that when you have a local variable or a method parameter that has the same name as a field, the local variable will take precedence, will shadow the field, because the compiler likes to use the closest definition it can find. Also, as a side note, classes are reference types, which means they are allocated on the heap and the stack cell points to that address on the heap. But classes also have multiple members, and obviously those also need to be stored somewhere. Thus, when we create an instance of a class, the runtime needs to allocate enough heap memory to store all those members. That's what I meant in the lesson about stack versus heap when I said that value types sometimes do go on the heap. If they are local variables, they are stored on the stack along with the stack frame that is created when you call that method. If they are fields, they are stored on the heap along with the entire enclosing class. Now let's get back to the scope of this lesson. The problem we have with the current code is that an int can accept any value, positive or negative, in the range it can store. So we could do this, and then we could assign it and get illogical values like this. You cannot have physically -1 stock. It's illogical. So in this case, we need a way to protect our application from illogical values, from invalid values. We need a way to validate the value before we assign it. There are multiple ways to do that. One would be to do what we did in the last lesson, where we ask the value as a parameter to the constructor, and then if it's invalid, we could throw an exception, etc. But that has two disadvantages. First, you need to know the value of the stock up front when you create the instance, which is not always the case. Maybe sometimes you only get that value later on. Second, it's only assigned when you call the constructor. So when you create the instance, that's the only time the constructor is called. Which means once you create that instance, you can no longer modify the stock. But then you'd say, why not create public methods, something like public void set current stock or something like that. And that's where you'd start to get closer to the entire idea of properties. In fact, languages like Java do exactly that. They offer public methods to get or set values of private fields. And C# took this idea further and added dedicated syntax constructs for this operation called properties. And they do more or less the same thing, but they are more concise in some forms. First, let's declare a property to see what we deal with. The first thing you'll notice as a beginner is that property syntax is hard to remember. It took me a long time as a junior to finally remember it. So to help with that, we have snippets. To get the original type of property, all you need to type is prop full or prop F, like this. And then if you press tab twice, you get the snippet for the original style of property. So first, notice that we do have a field, but this time is private. And then we have this construct, which is the property itself. I'll explain it piece by piece in a moment. But for now, we need to set the type of the property. In this case, it's int, which is exactly what we need. We can press tab to skip it and set the name of the backing field, which is the field that is used by the property, like this. And then if we press tab, we can set the name of the property. And if we want, we can assign an initial value. Now you can see that we have an error where we were setting the value of the field because of course this time is private, so it's no longer accessible. Now if I type my book dot, we get this current stock with capital C, which is this one right here. And it makes sense why it's accessible, because it's public. You also may have noticed that the icon of this member is different than the one we had before for the field. That's because properties have their own icon, this little wrench, and we can even filter only by properties with this other icon here. And this one is only for methods. Anyway, let's see what a property is made of. It has this block of code delimited by opening and closing curly brackets, and inside it these two constructs called accessors. The get part, also called a getter, has its own block of code, and the set part, also called a setter, also has its own block of code. And in the getter, we simply return this field, and notice the difference between the field and the property. One is with uppercase C, the other is with lowercase c, so they are different. So in the getter, we return the field. In the setter, we assign the field this value thing. Well, if I type my book dot current stock equals -1, this -1, when it's assigned to the property, is placed in this value thing, and then this value thing is assigned to the field. So this is the role of the value thing, to receive the value we assign to the property. And now you may say, okay, well, why we converted it into a property if we are still able to assign -1 to the stock? Yes, but the setter has a block of code, and if you remember, a block of code can contain multiple instructions. So we could do something like this. And in this case, we first check if value is less than 0. If it is, we throw an exception, so an error. And only if it isn't, we assign it to the field. So now the field will never have negative values. Let's get rid of this field assignment, we no longer need it. And if we run it, we will get an exception, because obviously we assign -1 and the check fails. So the reason why we use properties is to be able to control who and how can get or set values to and from our fields. And you may say to yourself, well, how often do we actually need validations like this? Most times you just want to read or set directly a field, so wouldn't making it public be easier? Yes, it would, but we use properties for two reasons. First, consistency. If you need properties some places, then you should be using properties for all the places. Second, explicitness. If a field is public, is it public by design to be accessible, or is it accidentally public? Is it a bug or is it not? So a property, by design, it is intended to be accessible. That's why you have a property, to access stuff. So the consensus among programmers is that fields should always be private, and if you need to expose them outside the class they live in, you should make a property for that. But you have to admit, this is a bit verbose. I mean, if you have to do this for every single field, that's a bit much, so we can do better. First, let's declare another property, this time of type string, and since we are not doing custom validations in the setter, it's already a bit better because it's on a single line, but for these cases, the language offers us a different kind of property called an auto-implemented property, automatic property, or auto property, whatever you want to call it, where we don't need a backing field, we don't need the entire getter, and we don't need the entire setter. And this is way better, only for the fact that since this is so simple now, we can write it on a single line. And for that case, we actually have a different snippet, which is prop. And if I press tab, now I get an auto-implemented property, where we only have the type of the property, string, the name, and the get set, nothing else. But don't let yourself fooled. If you don't see a backing field, that doesn't mean there isn't any. The compiler will generate it for you in the case of automatic properties. In any case, when you need custom validation, use full properties. In all the other cases, use automatic properties. Let's see some of the properties of these properties. So it is not mandatory to have both the getter and the setter. We can leave just the getter, in which case this becomes a read-only property. It cannot be assigned. So if we try to, we will get an error. In fact, this is a bit weird because it cannot be assigned even in the class it lives in. So the only place where a getOnly property can be set is in the constructor of that class or directly at the point of declaration like this. But you have to admit this is a bit extreme. I mean, in most cases, what we'd want is something that can be assigned in the class it lives in anywhere and be read-only outside that class. And for that, we have a private set like this. For the next part, I need to quickly show you something called an object initializer. But first, do you see these dots right here that say new expression can be simplified? Well, let's simplify it. And we get book my book equals new and parentheses to call the constructor. And this is the simplified shortened form because the compiler can infer from the left side what we are trying to do. If we say book my book equals new, etc., obviously we are trying to call the constructor of book. We will not say my book equals new product. So we don't have to repeat ourselves, it can be shortened and is much better. But we still have a second pair of dots and these say object initialization can be simplified. So let's simplify this one too. And we get this, which is the syntax for object initializers. And usually when you instantiate a class, you do something like book my book equals new, and then immediately after you set public members like mybook.currentStock equals, mybook.title equals, mybook, etc. equals. But that's error prone because you can accidentally reassign stuff that was previously assigned. And object initializers allow you to set public members immediately after you call new, but you cannot repeat them. So you cannot say current stock equals twice. And tied to this feature, we have init only properties where you have a getter, but you also have init. And init says that this property can be set at the point of declaration in the constructor of the class and in object initializers. And this practically is a middle ground between read-only, which can only be set at the point of declaration and constructor and nowhere else, and a normal property which can be set anywhere. If you want to force someone to set your property in object initializers, because right now title can be assigned in an object initializer but is not mandatory, if you want to force someone to do so, you can also specify required, and in this case they must provide a value for the title in the object initializer. Required also implies that whoever wants to instantiate your class must use this object initializer syntax, so it's no longer a suggestion, it's mandatory. And all this has to do with something called immutability, of which we will discuss at length on this channel. But basically, immutability states that the properties of an object should only be assigned when you create that object and be frozen afterwards. And that is desirable because the more you change proper values of properties, the more chances of errors you'll get. Starting with C#5, in the same style as expression-bodied methods, we also have expression-bodied properties, where we can change the accessors to use expression-bodied syntax like this. Oh, come on. Like this. But you should be careful with that because they behave differently from regular properties. To better illustrate what I'm talking about, I created a minimal example where we have two properties of type datetime. We haven't talked about datetime yet, but it's basically the way to get the current date and time in C#. And the reason why I used it is for both of them, I'm assigning this datetime.now. Now is the property that gives us the date and time, so the time changes all the time. The value of this property will be different all the time. And for the first property, I use the traditional format of property. And for the second one, I use this expression body syntax. Then, on the instance that I create, I basically print their value for both of them twice, one after the other, immediately after the other. So let's see what we get. As you can see, for the first property, the values are identical, but for the second one, they are slightly different. Why? Well, that's because datetime.now changes all the time. The time changes all the time, which means For the traditional format of property, when I assign it, the value that is assigned at that moment will be frozen there forever and ever until I reassign it. But for the expression body syntax, every time we try to read it, it will be reevaluated. Meaning, when I try to read it the first time, it's assigned and it's read. Then when I try to read it again, it's again read from datetime.now. So it's re-evaluated. And of course, datetime.now changed meanwhile, so the value is different. So you should be careful about using expression-bodied syntax because it has subtleties that even seniors don't know about. One last thing worth mentioning is the field keyword, which was introduced in C#14, which was just launched. That one allows us to have access to the backing field generated by the compiler without having to manually specify it. So we can use the field keyword, and that would give us access to that backing field. Sadly, I am not on C#14.NET 10, so I get compiler errors, but if you are using Visual Studio 2026, you will not get them. So basically, the field keyword allows us to strip one extra line. We don't have to manually declare a backing field. The compiler will generate it automatically and allow us to access it. At the end, a few tips. Some interviewers ask a trick question. They say, what is the value of this property? And you might give a value, and that technically will be incorrect because practically the value is not stored in the property. It is stored in the backing field whether you see it or not. The property, its only role is to mediate between this backing field and the user. So the user reads or writes this backing field through the property. The property doesn't store anything. Second, you can also have write-only properties. Properties that do have a setter but not a getter. So can you think of a case where you need a property that you can write into but you can never read? If you do, write it in the comments because I'm also curious about it. And now you can jump to like, subscribe, all that, because we are done for today. Thank you for your time and I'll see you in the next tech frame.